All right, we are covering section 6.2 today. This is over complex numbers and how we will solve by square roots. To start, we're going to start with solving quadratics using square roots. And if we have a quadratic equation that is in the form ax squared plus c is equal to 0, so we have the x squared term and we have the constant term, we can use the square root property to solve, okay? So we're trying to get x squared by itself on one side and then just a number by itself on the other side. So whatever we get when we're solving, as we get x squared by itself. If we have that, then when we take the square root of both sides to cancel out or undo that x squared term, then we'd be left with x is equal to the square root of n. And we have to make sure that we always have a plus or minus, okay? Thinking about why we have that plus or minus. If I take 3 and I square it, I'm going to get 9. But the same thing would happen if I take negative 3 and I square it, I would get 9. So the square root of 9 could be positive or negative 3. So just making sure we have that x squared, or that plus or minus in front of our square root, okay? Okay, so let's go into some examples. So I have x squared minus 64 equals 0. To get the x squared by itself, I'm going to move my 64 over. I'm left with x squared is equal to 64. And then remember, we are trying to get rid of that x squared, just get x by itself. So I'm going to square root both sides. I have x is equal to plus or minus, and the square root of 64 is 8. Okay. All right, next one. I'm going to undo my addition or subtraction first. So I have 7x squared is equal to 7. Then we undo our multiplication by division. I'm left with x squared is equal to 1. And solving by square roots, I'm going to square root both sides. So I have x is equal to, we know the square root of 1 is 1, so we need plus or minus 1. Same sort of thing on this next one. Undo our addition with subtraction. And undo our multiplication with division. This one, we get x squared is equal to 2. Again, we see x squared is by itself, so we can square root both sides. That's going to make x by itself. And the square root of 2 will not simplify, so I'm going to leave it as plus or minus square root 2. So simplify your square roots all the way if they will, to get to your final answer. Okay, if it will simplify, simplify the square root. All right, this one I'm undoing the subtraction with addition. And I am getting 64. We undo the multiplication with division. I'm left with x squared is equal to 32. We have x squared by itself, so we're ready to square root both sides. My 32 will break into 16 and 2. We know that the square root of 16 is 4, and the square root of 2 will not simplify. So I have x is equal to plus or minus 4 radical 2. So remember, you're pulling out the perfect square, the largest perfect square, in order to simplify your radicals. All right, don't let 5 trip you up. We want to move the constant first. I see a positive 4, so I'm going to subtract 4. Make sure you bring that negative down with the 3x squared. And I'm getting negative 81, negative 77 minus 4. When we divide, we have to divide by the negative 3. That's going to leave us with x squared is equal to positive 27. Square root both sides. I'm left with x equals, I know there's going to be a plus or minus. We think about breaking down the 27. I have 9 and I have 3. So I would have 3 radical 3 because the square root of 9 is 3. We subtract, we divide. I have x squared is equal to 60. When x squared is by itself, we square root. Since I'm taking the square root, I need that plus or minus. And I can break 60 into radical 4 and radical 15. The radical 4 will simplify to 2, and radical 15 will stay. All right. Number 7, we're getting the x squared by itself. Now I have x squared is equal to negative 81. I'm going to square root both sides. This time I am square rooting a negative 81. We still need our plus or minus, but remember, when we square root with a negative, we take the square root of negative 1 and the square root of 81. The negative 1 becomes I. The 81 is where we're getting that plus or minus 9. So I'm going to have plus or minus 9i. Okay, so if you are taking the square root of a negative, remember our I term will come in there. So I have negative 9 minus 15 is negative 24. And we divide. So I'm getting x squared is equal to negative 6. And I'm square rooting both sides. I see that I'm taking the square root of a negative. So I know I'm going to have an I term in there. But the square root of 6, radical 6, will not simplify. So I have plus or minus I radical 6. So we're taking that negative out from underneath and putting an I in its place. All right, and last one before we look at something new here. I'm getting negative 441, and we're dividing by 3. And I'm getting x squared is equal to negative 147. When I take the square root of negative 147, I am getting a negative 1, I'm getting a 49, and I'm getting a 3. So I know I'm going to have x is equal to plus or minus. The square root of 49 is 7. With that, square root of negative 1 is I, and the radical 3 will not simplify any farther. Okay, so really watch out for simplifying your radicals and simplifying a negative radical, negative square root, and how you have to bring that I term in. Okay, we are going to simplify our powers of I. So we know that I is the same thing as the square root of negative 1. Okay, so we would just have I. Well, if I is the same as square root of negative 1, I squared would be square root of negative 1 times the square root of negative 1. And the square roots would cancel each other out because we'd have our square root and our square. We'd be left with negative 1. So simplifying I squared, we just get negative 1. If I take I to the third power, I have square root of negative 1, square root of negative 1, square root of negative 1. We know that the I squared part is negative 1. And then we know this part would be I. So I would have negative I. Okay. And you can kind of break it down however makes sense to you. It might help you to think of this as, well, if I already know that I squared times I, if I know that I squared is negative 1, and I'm multiplying it times I get negative I. Okay, so thinking of it like that. With I to the fourth, I'm thinking of this as I squared times I squared, which we know that I squared is negative 1. So I have negative 1 times negative 1, which is positive 1. Okay, so lots of ways to think of this, but break it down with what you know. Okay, so I'm going to think of I to the fifth power as I to the fourth times I. Well, if I know that I to the fourth is 1, I have 1 times I, which is just I. Okay. I to the sixth power. I might break this one down as I to the fourth times I squared. I know that I to the fourth is 1, and I know that I squared is negative 1. So I'm just going to get negative 1. Okay. 7, I could do the 3 and the 4, I to the third, I to the fourth. We know that I to the third power is negative I, and we know that I to the fourth power is 1, so we're just at negative I. And I to the eighth, I to the fourth times I to the fourth. Not the only way to break this down, but I kind of like using one of my first 4 because it's easier to remember those 4 and then just kind of use those to help you. So I to the fourth is 1. And then I to the fourth is 1. 1 times 1 is 1. Okay, so breaking each of those exponents down into simpler terms so you can use that to simplify. Okay, so we are going to use some of those powers of I to help us out here. On this one, when I am multiplying 4i times 7i, I know the 4 times the 7, I get 28. And I know I times I get I squared. We cannot leave I squared in our answer. Okay, we got to make sure that we simplify it. Because we know I squared is negative 1, I'm going to have 28 times negative 1. So I get negative 28. Okay. On my next one, 2 times 5, I'm getting 10. I cubed times I to the first. Remember, we're adding our exponent, so I have I to the 4th power. You can always flip back to that powers of I, or you can remember it's I squared times I squared. Negative 1 times negative 1. We're going to get positive 1. So I have 10 times 1, which is just going to be 10. Okay. All right, back to simplifying some of our square roots here. So my 18 will break into 9 and 2. And since it's negative, we have that negative 1. My 10 will just break into a negative 1, and radical 10 will not break down any farther. So I'm going to have 3I radical 2 times I radical 10. Okay. I'm going to combine these. 3 times, there's like an imaginary 1 here. I'm going to get 3. I times I get I squared. 2 times 10 under the radical, I'm going to get 20. So 3I squared, 20. Okay. A little bit more simplifying left to do. Okay. 3 is going to stay the same. I squared, I'm going to go ahead and get rid of that and make it a negative 1. And my square root of 20, I can break into radical 4 and radical 5. So I have 3 times negative 1 is negative 3. The radical 4 is 2. And my radical 5 will stay the same. So I'm going to have negative 6 radical 5. Okay. So simplifying the square roots, then simplifying our powers of I all the way down to our final answer. Okay. Okay. And moving on to our complex numbers. So a complex number is kind of the mixture of a real number combined with an imaginary number. So it's complex. There's multiple parts to it. Okay. So if we had 5 plus 2I, we have 5, the real number part, and we have 2I, the imaginary part. Okay. It's a complex number. It's that combination of the two. They cannot be combined because one is a real number and one is an imaginary number. But when they're written like that, it is a complex number. So A is going to represent the real number part, and BI is going to represent the imaginary part. Okay, complex number. So we always want the real number first, the imaginary number second. When we are adding and subtracting, we're going to combine all the real numbers and combine all of the imaginary numbers, just like we would combine like terms, how we've done before. And when we're multiplying, that's when those powers of I will come in, and we'll have to make sure we simplify if we have anything other than just regular I. Okay? Okay, so let's jump in here on our first one. I see a plus sign, so I'm just going to ignore my parentheses, and I'm going to combine like terms. We want the real number first, so negative 11 plus 9, I'm going to get negative 2. And then we're going to combine our imaginary numbers, 3 plus 2i, or 3i plus 2i, and I get 5i. Nothing left to combine, just the real number first, imaginary number second, and we are done. Over here, number 2, I see addition again. So combine the real numbers. 4 plus 7, I'm getting 11. 1i plus negative 5i, I'm going to get negative 4i. Again, not combining those. One is real, one is imaginary. Leaving it in that form of your complex number. All right, on this number 3 here, I see a negative. I'm going to think of this as a negative 1, and I'm going to distribute that negative 1 to everything in the second set of parentheses. I have not changed the first set of parentheses, so that's going to come down. Negative 1 times 2 is negative 2. Negative 1 times 6i is negative 6i. Once you have taken care of that negative or that subtraction, you're ready to combine like terms. Just like we did on the addition problems. All right, looking at number 4, I have a couple different operations. I have a negative here, and then I have a positive or a plus. So I'm going to distribute my negative 1 to take care of that subtraction. So I have 6i minus 14 plus I, negative 1 times negative I. Then I'll just bring down the plus 5 minus 3i. Nothing changes on that part because we're just adding it in. We're ready to combine like terms. I'm taking my real numbers and I'm getting negative 9. I'm taking my imaginary numbers. 6 plus 1 would be 7, minus 3 would be 4. So I have 4i. Making sure it's in that complex number form. Real number, then imaginary. So if you see that subtraction, you're distributing the negative 1 and then combining like terms after. All right, and then these last 4 are dealing with multiplication. So we're going to think of these as if we're like multiplying binomials, trinomials, things like that. If they were x's, what we would do with our exponents, we're still doing the same thing with our exponents on I. So I'm going to take 2i times 8. I'm getting 2 times 8 is 16. Keep the I with it. 2i times negative 3i. 2 times negative 3 is negative 6. I times I is I squared. We know that I squared is equal to negative 1. So I have 16i minus 6, but in place of I squared, I'm going to put negative 1. 16i plus 6, but we need to get this in the form for a complex number. We need the real number first and the imaginary part second. So 6 plus 16i. All right, over here on number 6, I have negative I times negative 2 would be positive 2i. Negative I times 10i, negative 10i squared. We know that I squared is negative 1, so I have 2i minus 10 times negative 1. So I have 2i plus 10, and we're going to flip that around, 10 plus 2i, so it is in our complex number form. All right, last 2 here with multiplication. Here's where we're going to make sure we distribute the 7 to both terms in the second set of the parentheses and distribute the I to both terms in the second set of parentheses. So I have 7 times 4, I'm going to get 28. 7 times negative I, negative 7i. Now the I times 4, 4i, and I times negative I squared. Okay. I'm going to combine my like terms. So I have 28 minus 3i, and then I'm going to go ahead and substitute in, because I know that I squared is equal to negative 1. I have 28 minus 3i minus negative 1. Okay. And I'm going to show lots of my steps here so we can follow what's going on. You'd be able to do these in a few other steps, or fewer steps if you wanted. So I have 28 and positive 1, because the minus negative. Combine my real numbers. I'm going to get 29 and minus 3i. It is in my complex number format, real number, then imaginary. Okay. So still replacing that I squared, but you have the added step of combining some like terms there. All right, and number 8. 2 times negative 5 is negative 10. 2 times negative 3i is negative 6i. Negative 4i times negative 5 is positive 20i. And negative 4i times negative 3i would be positive 12i squared. Start with combining like terms. I'm going to get positive 14i. Then I need to replace my, I forgot the squared. I need to replace my I squared with negative 1. So I have negative 10 plus 14i plus 12 times negative 1. Again, you could probably do this in fewer steps. I just want you to follow what's going on here. So that 12 times negative 1 got me negative 12. And I'm going to combine my real numbers. Negative 10 and negative 12, I get negative 22. And I bring that plus 14i for the imaginary part. Negative 22 plus 14i. So when you're adding, you're just combining like terms. Subtracting, distribute the negative 1, then combine like terms. And multiplication, multiply, add those exponents, make sure that you are simplifying if you have your I squared in there.